Today we're going to discuss collisions and the different types of collisions that exist. When we talk about collisions, we're talking about when two objects hit each other. All right, we're going to keep it to two objects. Sometimes there's more objects involved in a collision, but we're going to keep it to two. So a collision is when two objects hit each other, collide. When they do that, they exchange energy and momentum. And if you remember from our conservation of momentum video, we talked about that energy and momentum are never lost. So during the collision, and keep in mind, we're talking about in the absence of external forces such as friction. So on Earth, this is a theoretical thing. All right, when two cars hit, there is friction. All right, there are other forces acting on the collisions. We're talking in a theoretical world where there's no friction. The net momentum before the collision equals the net momentum after the collision. What types of collisions are there? There's two types that we're going to discuss this year. There's elastic collisions. Little trick to remember that. I think of elastic, I think of something that's bouncy. All right? So in elastic collision, the objects bounce off one another without being deformed. And then we have inelastic collisions, in which the objects actually hit each other and deform. Like, think of like a baseball bat hitting into a tin can or a soda can. It's going to hit it and crush it. Okay? They stick together. Or think about if you ever stepped on a soda can on your heel. You step on the soda can and all of a sudden it becomes part of your foot. Okay? Or if you want to imagine two cars hitting together and sticking and moving across the road. So when we talk about types of collisions, we're talking about, we mentioned the elastic collision. In this situation, the objects will hit and bounce off each other without being deformed. So they'll keep their shape. Deform meaning that they don't stick to one another. In an elastic collisions, the momentum of one object is going to be transferred to the other object. So in this scenario, the momentum, which can be calculated of car A, is going to be transferred to the momentum of car B. Notice the negative sign here. Remember that the negative sign in these scenarios means opposite direction, right? Because when we're talking about momentum, momentum is a vector measurement or a vector quantity, which means it has direction. So if we said before the collision that cart A has a velocity of 5 meters per second and cart B has a velocity of -8 meters per second, which means 8 meters per second to the left, and cart A has a mass of 10 kilograms and cart B has a mass of 10 kilograms. All right, so they have equal masses. When carts have equal masses, their velocities will simply just be exchanged. In this situation, we calculate the overall momentum of cart A, and the overall momentum is going to equal 50 kilograms times meters per second. The momentum of cart B is going to equal -80 kilograms times meters per second. So -8 times 10. So if you remember, we said in an elastic collision, the two objects that collide will have, that if they have equal masses, the velocities are exchanged. All right, so the velocity of cart B is going to be transferred to cart A, and the velocity of cart A is going to be transferred to cart B. So now, remember, they come together, they hit, and they bounce off back in the opposite directions. All right? So now think about that. The velocity here is going to be 5 meters per second, and the velocity over here is going to be -8 meters per second. All right? So the net momentum of the system is still the same. If we wanted to calculate the net momentum of the system, we simply add together the two momentums. All right? So momentum of A is 50 plus -80, so the net momentum of the system is -30 kilograms times meters per second to the left. So the momentum of A is 50 kilograms times meters per second. B is -80 kilograms times meters per second. And in order to calculate the net momentum, we add them together. The net momentum of this system is -30 kilograms times meters per second. If we're talking about inelastic collisions, these are collisions in which objects become deformed and they stick to one another. So if they have equal masses and opposite velocities, the net momentum will be 0. So if the net momentum is 0, the objects will hit, stick, and stop. And we'll show you that. So if you have a 10 kilogram mass moving at 5 meters per second to the right, and you have another 10 kilogram mass moving at negative 5 meters per second, all right, which would be 5 meters per second to the left, they will hit and stick and stop. Calculating the net momentum, if you do car A is 50 kilograms times meters per second, car B is negative 50 kilograms times meters per second. If you add those together, 50 plus negative 50, the net momentum is 0 kilograms times meters per second. Another type of inelastic collision would be if one of the objects is at rest. If one of the objects is at rest, the net momentum before the collision will be shared by the combined mass after the collision. Okay, what the heck do we mean by that? Look, so if one object is rest, it's not moving, and it has a mass of 10 kilograms, and that's cart B. Cart A has a mass of 10 kilograms, but it is moving at a velocity of 10 meters per second to the right. All right, I liken this to two railroad cars. All right, you have one that's sitting still, one's moving, they hit each other, and they hit, they stick, and they start to move forward, but at a slower velocity. So what's going to happen here is actually you're going to have the net momentum is going to be the same, but the velocity, therefore, is going to have to be half because you're doubling the mass. So in this overall system, we have overall net momentum because this one's not moving, so its momentum is 0. The net momentum is going to be the total momentum of the moving car, car A, which is 10 times 10, which is 100 kilograms times meters per second. Now, after they hit, they stick, and now they're going to move. But if they're moving, you have to realize you have 10 kilograms plus 10 kilograms of mass because they're all together now. So your equation changes slightly. Your momentum stays the same, but it changes your equation because the momentum, which is 100 kilograms times meters per second, now equals, instead of 10 kilograms times the velocity of 10 meters per second, 20 kilograms. So now you can calculate the velocity out by plugging it into your formula. So they're giving you the momentum, which is 100 kilograms times meters per second, and you can divide that by the new overall mass of the moving object, which is 20 kilograms. So 100 divided by 20 equals 5 meters per second. The new velocity is going to be moving to the right at 5 meters per second. Okay, and that's basically what we're going to discuss this year when we talk about collisions. If you have any questions, please feel free to ask as we circulate throughout the room. Okay, have a great night.